We're going to be starting our trigonometry unit, our first trigonometry unit out of 3, and we're going to start off by talking about right triangle trigonometry. Now, most of what we're going to talk about today, hopefully, is review from geometry, which may have been a little while ago. And so we're just going to go over the basics of right triangle trigonometry today, make sure we're all on the same track, make sure we have a good review of all of those concepts. So your basic trig functions are the ones that you should have learned back in geometry. And the first one is sine. Sine is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. And we can abbreviate using the first 3 letters for each of those: sine, cosine, and tangent. Now, the other 3 trig functions that you may not have seen previously are called the reciprocal trig functions. These are cosecant, secant, and cotangent. Now, just as their name suggests, these are the reciprocals of sine, cosine, and tangent. So sine, the reciprocal is cosecant. So that's that hypotenuse over the opposite side. The reciprocal of cosine is secant, so that's going to be the hypotenuse over the adjacent side. And then the reciprocal of tangent is cotangent, and that's the adjacent side over the opposite side. You do need to have these memorized, so hopefully if you still remember SOHCAHTOA to remember sine, cosine, and tangent, then you just have to remember for the reciprocal trig functions which pairs with which, so sine with cosecant, cosine with secant, and tangent with cotangent. Once you know those pairings, then it's just a matter of flipping those ratios. Now, a couple of reminders as we get into right triangle trigonometry. In general, if you are going to use decimals for trig values, do always round to 4 decimal places. This will particularly be helpful if you are trying to use that in order to solve for something else in the problem. 4 decimal places will help you be as accurate as we can. Now, if you end up just plugging the entire thing into the calculator, that's fine, but sometimes you might find it more useful or more helpful to write down what the trig value is before you continue the problem. So in that case, round to 4 decimal places. Another thing, make sure that your calculator is in degree mode. So your calculator has 2 modes when it comes to trig. One is degree mode, one is radian mode. And on the calculator, you want to make sure that you're in degree mode, at least for now, when we're doing calculations with right triangle trigonometry. We'll talk about radians later on in this unit, but for now, we'll just stick to using degrees. Now, if you're not sure if your calculator is in degree mode or not, here's the way you can check and how you would be able to change it. So in the top left corner, next to the second button, there's a button that says Mode. You want to click on that. And depending on which version calculator you may have a row of different things. You want to find the row that says radians and degrees. For some calculators, this may read DEG for degree and RAD for radian. Scroll down and make sure that degree is highlighted and hit enter. And then you're in degree mode. Generally, it will stay in degree mode until you change it again, unless you reset your calculator. Okay, another couple of reminders. Make sure you use parentheses when you are using the calculator. A lot of the times you might have, let's say, tangent of 42 degrees times another number. You want to make sure you close the parentheses on the tangent before you multiply by that number. Otherwise, it will take the tangent of everything that you're writing in. And then reciprocal functions on the calculator. So if you are trying to find, for example, cosecant, you'll notice there is no button for it as there are for sine, cosine, and tangent. If you're trying to find cosecant, remember it's the reciprocal of sine, so you would want to do 1 divided by sine of whatever the degree measure is. What you do not want to do is you do not want to use the button that says sine with a -1 that looks like it's in the exponent. That's the inverse of sine. So make sure you don't use that if you're trying to find cosecant. We use sine inverse to solve for an angle measure. It's the inverse of sine, which is different from the reciprocal of sine. Okay, so just as a reminder of how that is used, sine of theta will give you some trig value. So if you know what the trig value is and you want to find theta, you would then use sine inverse of the trig value to get you the angle measure. Okay, let's take a look at example 1. Given sine of theta is equal to 3/5, find cotangent of theta. Now if it helps you, let's go ahead and draw a picture for ourselves. We're working with a right triangle, and let's say that theta, our angle measure, is over here. And if we know that sine of theta is equal to 3/5, that means that the opposite side is 3 and the hypotenuse is 5. That leaves us with one side left. Now, if you recognize these numbers, they are part of the Pythagorean triple. If you don't recognize the Pythagorean triple, that's okay. You can still use the Pythagorean theorem to determine the last side, which will be 4. So cotangent of theta, remember that's the reciprocal of tangent. Tangent, remember, is the opposite over adjacent. So cotangent is going to be the reciprocal of that, so that's the adjacent side over the opposite side, which is going to be, in this case, 4/3. Okay, example 2. Solve the right triangle given. So if you recall, anytime you're asked to solve a triangle, that means you are trying to find the measure of all the missing sides and all the missing angles. So in this problem, we notice that there's one angle measure we still need and 2 sides that we still need to find. We can start by saying, okay, I need to find this angle here, this side here, and this side here. We'll just label everything. Starting with the angle measure. Why? Because, well, we already have 2 angle measures, and the triangle sum theorem tells us that we can subtract both angles from 180, and what is remaining will be the angle I'm looking for. So theta is 180 minus 90 minus 65, and that comes out to be 25 degrees. Now we still need to find the value of x and the value of y. So let's say we start by finding the value of x. Now I'm going to use the angle given to us, the 65-degree angle. You can technically use the 25-degree angle as well. Now if you want to be on the safe side in case you messed up on some part of the calculation of that angle, then I would say stick with the measurements that were given to you. So if I'm looking at the 65-degree angle, I'm trying to find the measure of x, and I have the measure of the hypotenuse, which is 8. X is opposite the 65-degree angle, so since I'm solving for the opposite side and I have the hypotenuse, I want to use sine. So sine of 65 equals x/8. Now we need to solve for x, so I'm going to need to multiply both sides by 8. So now I have 8 times sine of 65. Now if you want to, you can put that entire thing into the calculator, 8 times sine of 65, and then round that to 1 decimal place. What I was referring to earlier when I was saying that you need to make sure that you have 4 decimal places is if you were going to put in sine of 65, get a number, and then multiply that by 8, you want to make sure you have at least 4 decimal places there. Okay, and then the last measure for y, again, you actually have a couple of ways that you can go about solving this. Now that you have 2 sides of the right triangle, you could use the Pythagorean theorem. It won't be quite as accurate because we have done some rounding for x, so I would suggest using another trig ratio in order to solve for y. So since y is adjacent to the 65-degree angle, and we were given the hypotenuse, which is 8, we can use cosine, which is the adjacent, over the hypotenuse, So that would be cosine of 65 equals y over 8. Multiply both sides by 8. And we're left with y equals 3.4. And so we were able to find all the missing angles and all the missing sides, so we were able to successfully solve the right triangle that was given to us. Okay, let's look at one more example that involves solving a right triangle. In this case, unlike the last problem, we're missing two angles and one side. In the last problem, we were missing one angle and two sides. So let's go ahead and label everything that we're missing. So we're missing this angle here, we'll call that theta. We're missing this angle here, we'll call that beta. That's another Greek letter. It kind of looks like a B with a little tail at the end. And then we'll label the side that's missing as x. Now, unlike the last example where the first thing we did was to solve for the angle measure, because we had two of the angle measures, we just had to find the third one. In this one, we have two of the sides, so it'll actually be pretty easy to find the last side. So let's start with x. We can use the Pythagorean theorem, so 3 squared plus 4 squared equals x squared. Or again, if you recognize the Pythagorean triple there, you can say that by Pythagorean triple, you know x is equal to 5. Now let's go ahead and solve for the angle measures that are missing. Let's start with theta. Now again, I'm going to use the measures that are given to us, the measures of the side given to us, just in case we messed up on any previous calculations. So to find theta, we look at 3 and 4 and how it's related to theta. So 4 is opposite angle theta, and 3 is adjacent to it. Okay, if we have the opposite and the adjacent sides, then we probably want to use tangent. So tangent of theta is equal to 4 over 3. Now, how do we solve for theta? This is where using the inverse trig function will come in handy. So in this case, the inverse tangent function. So what we're going to do is we're going to take the inverse tangent of both sides. And what that does is on the left-hand side now, tan inverse and tan will cancel each other out. That leaves us with theta. So theta is equal to tan inverse of 4 over 3. And putting that into the calculator, we get theta is equal to 53.1 degrees. Again, at this point, you have multiple options in terms of solving for the last angle measure. Since you have two of the angle measures now, you can subtract from 180 to get the last angle measure. For practice, we are going to go ahead and use another trig ratio to solve for beta. So in relation to angle beta, 3 is opposite angle beta and 4 is adjacent to it. So again, we'll use tangent, but this time 3 is opposite and 4 is adjacent. We'll do the same thing as in the last step where we took the tan inverse of both sides. That way tan inverse and tan will cancel each other out. That leaves us with beta on the left. And so we have beta is equal to tan inverse of 3 over 4, plug that into the calculator, and we get beta is equal to 36.9 degrees. And we have successfully solved for all the missing sides and angles in this problem. Now let's talk a little bit about trig applications. So for right triangle trig applications, when you draw a picture, be sure to include a right triangle. For the most part, unless the problem tells you otherwise, you can assume that trees, buildings, anything that they say is a certain height is at a 90-degree angle with the ground. The other term that you might hear is angle of elevation or angle of depression. And so we need to understand what those mean. So angle of elevation refers to the angle that's formed as you are looking up from the horizontal, whereas angle of depression is the angle that's formed as you're looking down from the horizontal. So just as a diagram here, if this is the horizontal and you're told the angle of elevation as you look up towards whatever it is, the top of a building, the angle of elevation that's created is a certain degree. So this would be elevation as you're looking up from the horizontal. And so the angle that's formed by the horizontal and that line of elevation, that angle is the angle of elevation. Angle of depression, if you're looking down from the horizontal, so say I draw this line here, this would be your line of depression, and so the angle of depression is the angle that's formed by the horizontal and that line of depression. Let's do one application problem. A surveyor is standing 50 feet from the base of a large tree. The surveyor measures the angle of elevation to the top of the tree as 71.5 degrees. How tall is the tree? Let's start by drawing in a picture for ourselves. Again, unless you're told otherwise, you can safely assume that anything that you're told about a tree, a building, will be at a 90-degree angle with the ground. So here's the tree. It's standing upright. The surveyor is standing 50 feet from the base of a large tree. He's a surveyor, and he's standing 50 feet from the base of the tree. The surveyor measures the angle of elevation to the top of the tree as 71.5 degrees. So here I've drawn that line of elevation, and the angle that's formed by the horizontal and that line of elevation, that is the angle of elevation. So that angle there is 71.5 degrees. Now you're asked, how tall is the tree? I'm going to call the side of the tree here. I'm going to call that h because we're finding the height of the tree. Okay, if you need to draw a right angle in there, you can, but the right angle should just be the angle formed by the tree and the ground. So now we're trying to find the measure of h. That's the side that is opposite the 71.5 degree angle. And then we are given the measure at the bottom there, the 50 feet, and that's adjacent to the 71.5 degree angle. Since we're solving for the opposite side and we are given the adjacent side, we want to use tangent. So tangent of 71.5 degrees is equal to h over 50. Now we solve for h, multiply both sides by 50. 50 cancels on the right. And we're left with 50 times tan of 71.5, which is equal to about 149.4 feet.